Hello, my wonderful students. Let's talk about combining and breaking up vectors into the x and y components. Now, the whole point is I'm going to teach you a series of steps on how to think about vectors, both combining them and breaking them up. Now, the reason we're doing this is because it's really easy to combine multiple different things. For example, multiple walks, multiple velocities, or even multiple forces. The whole, you go right, then left, then up, then down, blah, blah, blah. So the first thing we dealt with in class are all these really easy ones when they're all in the same kind of general direction. Like, for example, you have a bunch of different walks going left and right. So I drew a couple numbers here. A bunch of rocks to the right, and then a couple to the left. And all you do is just add all the rights up, subtract the lefts, and you get a total amount. So 4, 3, and 2 right, and 3 and 3 left equals, to the right, a value of 3. Not a big deal. Same with up and down. If you have a bunch of ups and downs, you know how to combine them into one overall value. So if I just give you a bunch of left and right or up and down separately, it's not too bad. But what happens if I give you a left and right and an up and down to combine? You can't just add them up. You can't add 3 right and 4 up because they're completely independent. I'm going to redraw the force pink just to help us visualize it. What you're going to do is how I draw them this way. The 3 first and then the 4 from the tip of the 3. And that gives you that purple result, which is how many you walk overall with some angle. That forms a right triangle. And because of that, the resultant, or what you want, is the hypotenuse. Now, if you draw it like from the same point, like I did right there, then you can't really tell where the overall is, and it doesn't really help out. It's horrible. So we draw one, then the other from the tip. If you want to find that resultant, it's the Pythagorean theorem. And you get 5. So a walk of 3 right and 4 up is a total of 5 steps. 3 is the x component, or the horizontal component here. 4 is the vertical component, or the y component here. They're both positive because the 3 is right and the 4 is up. So again, I can think of it as if I walk 5 at that exact angle, it's like I walk 3 to the right, then I walk 4 up. It's a way of thinking about things. So I just drew a beginning vector. You're going to see it in a second. But let's say we have two vectors, something in the angle and 4 to the right. If you were to try to draw it, it does not give you a right angle together, which makes it's not very possible to do. So if you walk 7 at some angle and then 4 to the right, you can't really do it easily. So let me show you how to make this into a better situation with the right triangle. So we need to turn that 7 at an angle and that 4 right into an overall right triangle. From there, it becomes super easy. So what we're going to do is we're going to turn that 7 into its own personal right triangle. Because if we can get it to a right and up, we can combine everything else, and that's easy. So watch as I do it. There's my 7 at angle. I'm going to draw on the x part and then the y part. I'm labeling them x of the 7 and the y of the 7. I don't know the values, but they're the x and y components of the 7. So then, the 7 part of the x, the x part of the 7 plus the 4 gives me my total x. And the y of the 7 is by itself because the 4 has no up or down parts. It's just 4 to the right. And once I can combine them, I can get 1 overall x, 1 overall y. I can do the Pythagorean theorem. So let's write down how to get the x and y components from a situation. The first thing to do is I want you to draw in the x and y parts of your vector so they create a right triangle. And the theta should be inside of that right triangle. So again, there's the one I just did. I start at the butt and I draw my first vector. I have to draw right because I don't want to draw up because I want the right triangle to be with the angle. So that's why I drew it right then up. Look at this next one I'm drawing. I just made it up. There's 12 at some angle. I'm going to go down first and then left because I want to have a right triangle with the angle inside. There's my angle, 3. I'm going to go right, then down. Let's have them x and y for all of them. And now, for the second point, we're going to assign the x's or y's positive or negatives based on which way they're pointing. So the first case, they're both positive, right and up. The next one, left and down, they're both negative. The third one, right and down, right is positive, down is negative. Then I'm going to assign them adjacent or opposite of the right triangle based on where the angle is. So in the first one, the x is adjacent, the y is opposite. For the next one, the y is opposite. I'm sorry, the y is adjacent, the x is opposite. And for the third one, the y is opposite, x is adjacent. Look at which one is actually touching the angle. And then finally, I'm going to use sine and cosine to get the x and y parts. Why don't you do the first one? Cosine is always adjacent over hypotenuse. In that picture, cosine theta 1, adjacent is that positive x, and the hypotenuse is the 7. Moving 7 over, I get the x part is 7 cosine theta 1. The y is opposite. Sine is opposite of hypotenuse. So sine of theta 1 is the opposite, which is positive y, over the hypotenuse is 7. So 7 sine theta equals y. For the next one, cosine is adjacent of hypotenuse. Cosine of the angle is this time adjacent to y, so it's negative y over 12. And I could solve for y. So you see how I do it there. I constantly look at what's adjacent, what's opposite, and you sine and cosine, and end up solving for the x and y parts. So far, that 7 at an angle plus the 4 to the right. What I've done is I found x and y parts. The x part, I found it to be 7 cosine theta 1. The y part I found to be 7 sine theta 1. And the purple part is still 4 to the right. There's no y part because there's no up and down portion of it. Now to combine them, we want to get an overall value. We're going to call that the resultant. Again, we want to get a hypotenuse of this combined values. So we're going to make an x and y table. In the x, there are two different vectors, so I'm going to write them as the 1 and 2. And then underneath them, write them the sum. That's the Greek letter sigma for total. You can see I label them x1, y1, x2, and there's no y2. So x1, I'm going to put there, 7 cosine theta 1. The y part is 7 sine theta 1. Positive and positive. The next one, the 4 is all in the x, there's no in the y. So now I add them up. 7 cosine theta 1 plus 4, 7 sine theta 1. Those are my x and y parts, and if I create a right triangle with those in it, I can get the result and how many steps it is, using x is that and y is that. It's been a pleasure.